All right, here we go on the flowchart unit review. So I'm just going to say these out loud. If you're missing stuff, just go find it. Metric system based on the number 10. There are 4 base units. Okay, so there are 4 base units, and then we're going to split it up over here. The base unit for weight and solids is the gram. The symbol for this is G. We measure weight using a balance or a scale. All right, what about our base unit for volume or liquids? This is the word liter. So this is not specifically like how do we measure it, but what's the base unit? What word do you hear? We hear the word liter. Now, when we are using just a symbol, it's just L. And then, like, how do we measure stuff like this? For like a rough measurement of liquid, we're going to use a beaker. For an exact measurement, we're going to use a graduated cylinder. When you're using a graduated cylinder, you're going to read from the bottom of the little U shape that forms. And the bottom of this is known as the meniscus. Now, when you are using a graduated cylinder, make sure you know how much each line is going by. This is known as the increments. All right, what about number 13? There are 2 ways to measure volume. So let's go off on this branch first. The first way is called indirect measurement, which is using water displacement, fancy word for saying moving water. And we know that 1 ml of water that is moved is also equal to 1 centimeter cubed, or cm to the 3rd power. Now, why is that 3 there? Okay, why is it cubed? Well, what does it stand for? It stands for length, width, and height. If you said something like dimensions, okay, but really what you're looking at is length, width, and height. Now, what about this one right here? What is it called when we actually are measuring length, width, and height? We call this direct measurement. So indirect measurement versus direct measurement. So volume, we're talking about volume. Volume is how much space something takes up. Now the base unit is the liter, but when we measure it in class, we're using the milliliter or the centimeter cubed. All right, what about the base unit for length? The base unit for length is the meter. What is the symbol? M. And make sure when you're using a ruler, you start off at the 0 mark, not at the edge. All right, let's move over to 22. There are 10 basic rules for this class. Take a look inside your notebook. You will see them. So report any accident to the teacher, no matter how minor. Okay, so any accident, no matter how minor. Don't wait till the end of the period. Okay, just let me know right away. Prepare for each laboratory activity by reading instructions before coming to class. Also, our protocol person helps out with this. They're the ones who actually read it during the lab. Make sure you look at the notes for like those little extra details that we added in between lines. Okay, number 25. An instructor must be present, or a teacher must be present during all laboratory work. Confine long hair, tie long hair, confine or tie long hair will work. All right, wear appropriate eyewear. If you say wear appropriate goggles, okay. If any chemical spills in lab, let the instructor know immediately, unless it is water. So unless it is water, I don't need to know about water. All right, number 29. Always clean the lab area before leaving. You guys have done a good job of this. All right, down over here. Number 30. So number 30, a cube measures 2 centimeters by 2 centimeters by 100 millimeters. Do not just straight multiply. You got to go 2 times 1, and this needs to get converted over to centimeters. If you use your step chart, this moves over 1 to the left, so that's 10 centimeters. So it's 2 times 1 is 2 times 10 centimeters is 20 centimeters cubed. So 2 cm to the 3rd power. You could also write it as 20 mLs. All right, what about number 31? Number 31. The final volume is 16 mLs. Or sorry, the initial. It starts off at 16. The final water level is 26 mLs. So what is the object's volume? Well, final minus initial is 10 mLs or 10 centimeters cubed. All right, what about number 32 over here? If you move blank on the step chart, your decimal moves to the right. So if you move to the right on your step chart. So again, if we're going this way, so if we're going from meter to decimeter, your decimal moves to the right as you move to the right on the step chart. If you're going from meter to decameter, so to DAM, you move left, that means that your decimal will move left. So really your number is kind of getting smaller. So you're going to go from like 22 to 2.2 decameters. So these are conversion problems. I'm not going to go through all of them. You should know how to do it. But I'll go through the first one. So you're going from kilograms to grams, so 5.67 kilograms. So you're here trying to get here, and that means your decimal is going to move 1, 2, 3 to your right. So I'm going to come back over here. So if I were doing this, I would be moving my decimal like 1, 2, 3, not the greatest. So I'll do it over here, 5.67. So I'd go 1, 2, 3. My decimal would stay there. I put in a 0, so 5,670. This one, again, is asking you to go from deciliters to deciliters. So I know that I'm moving to my right this way. So my number is going to get bigger. And I know that so like I just know this because I've looked at it enough. But like if you need to, so you're coming from here, 1, 2. It's a 2-step. So I know I'm coming 1, 2. So this would be 78 deciliters. So do the same thing for seconds. If you move, so these are basically going to the right. These right here are going to the left. So your numbers will get smaller. So like 9 seconds to, oh, I'm sorry, I'm looking at this. So we're going from meters to kilometers. I know that it's 3 steps. 1, 2, 3. Your answer would be like 5.6397, like that. And I think that number 40 right here. This is a great question. So if there's an air bubble in an object that you're measuring and you don't realize that the air bubble is there, explain why the volume would be higher or lower. So if you had a flask, right, which you did, and it has air inside of it, and I want just the volume of the glass. When you put this into water, so let's just say the water gets to right here, okay, it doesn't fill the empty space, you're going to get a volume that's higher than it should be. This is why in the lab you guys were getting numbers like 200, like way too high, way too high. If you subtract out the air, then you are left with just the volume of the glass. All right, this is just a thought question, but a test question nonetheless. Let's just say you're using indirect measurement and you spill water, okay, and you're supposed to collect it. So let's say you're doing the pink ball, you like throw it in, and water splashes out. Remember, you have to collect it in the beaker. So what happens if water spills out by accident? What will happen to your volume? Now, this water is supposed to make it here, and you're going to measure this in the graduated cylinder. So let's just say it's supposed to be 30, but because you threw it in so hard, 10 ml spills out. So when you get your volume, it's going to look like it's 20 ml. The volume is going to seem smaller than it actually is because you lost water that you weren't supposed to lose. All right, what about this thought question? What happens if you forget to dump out the water in the beaker? Okay, you don't put the ball in, there's like 10 mLs in here. You don't notice, you forgot to dump it out. And then you put the ball in. Well, slowly, you put the ball in. Well, the water is gonna begin pouring in, and it's gonna think that the ball is this plus what the ball actually is. And so what's gonna end up happening is you're gonna end up with a volume that is higher than it should be, because it's going to think this plus the ball is the volume of the ball. So for tomorrow, like I said, make sure that you're able to go through these, and you should know them pretty quickly. Like it took me less than 10 minutes to go through everything and kind of explain a lot. You should be able to fly through this. Please don't try to memorize these things. Like I said, it's mainly about concepts and understanding. If you're having trouble with something, like I said, maybe shoot me a Discord message before 8 o'clock and I will try to get to it.